Hey, good morning. Today we're going to start kind of solving quadratics without graphing. And when we talk about solving quadratics without graphing, all we really want to know is sometimes is on our parabola, if it goes something like this, sometimes we just want to know where did it start, where did it end? And then sometimes we'll say, well, how long was it in between these two dots here? And we can measure that. Maybe we're not too concerned about how high it went or any of these dots in between. Right now on roots, when that's another way of saying the zeros, all we care about is the two places where it maybe like leaves the ground or hits the ground. So here's our warm-ups, getting us ready for today because we have to know how to factor. And that was what our whole last section was about. And our last test was about, can I factor quadratic equations, because that's going to help us find our zeros/roots. So do these warm-ups and pause your video and then come back when you're done. All right, let's see how you did. We call this the zero of a function. When f of x, that's a function, and if it equals 0, we call those the zeros. All right, so number 2, I'm hoping you did okay on. Again, over here, you just can put this x method to find those two magic numbers, a minus 88. They have to multiply up to and add up to a 3. And that would have been 11 and 8. And so one of them had to be a negative in order for that to be a negative up there. So all you had to do is plug those numbers in. Over here, you had a little extra work to do. Maybe we can do it real quick here. In case you missed it, refresh your memory because it's important. So we took this number and we multiply it times this one, and that's a minus 30. And we have a minus 7 in there. And so now I'm looking for two numbers that multiply to 30, a negative 30, but add up to a negative 7. And so if we did 10 and 3, one of them has to be a negative. And so we can say this one has to be the negative. So then what we did is we wrote, my method here is 6x squared minus 10x plus 3x minus 5. Then we did the squiggly line because I have 4 terms. I factored out a 2x out of the first term. So then I have 3x minus 5. Automatically write 3x minus 5 over here. And what times 3x gives me 3x? 1, and it gives me 5. And so, where did I mess up here? Oh yeah, 2x plus 1 is one of my factors. I didn't mess up. And 3x minus 5 is my other one. It doesn't matter the order of the factors there, okay? I'm hoping that you recognize that this was a perfect square down here. And we should always look all the way across first, like on number 5. Is it in order? Yes. And can we factor anything out? And so I factored out a 3 right off the bat. And that gave me a 4x squared minus 9. And we call that a difference of a perfect square because my middle term is 0. That's a perfect square of 2x. That's a perfect square of 3. And so 2x plus 3 and a 2x minus 3. So these are all the factors, perfect, all the way to the end. Okay, all right. I'm hoping everybody's doing okay on those because we spent a good amount of time on that. So today we're going to look at, trying to figure out how long a diver is in the air for, and that's kind of our goal here. And on these 2 problems, I guess, what they're not telling you is there was a quadratic equation like up here on our warm-ups, and they already factored it. So it was something like number 2 here where they said, okay, there's a quadratic equation, we're going to factor it because we want to go to the zeros. And once our quadratic equation is set to or factored, what we want to do to find the zeros is x minus 3 equals 0. So what we do is we set our factors to 0, we call it. And we have x plus 7 equals 0. And now we just get our x's by itself. We add 3 to both sides on this one. And this one we're going to subtract 7. So then we have our zeros. Let's call them roots today, just so we get in the habit of that roots and zeros are the same thing. So the roots are, and usually you put the smallest one first, -7 and 3. We put the smallest one first because when we're looking at a graph, we usually read the graph from left to right. Now, they said to check your answers, and we'll just check it on one. And so, actually, we can't check it because they didn't give us the actual equation. Let's see. They said check our answer. So, I'm not sure if they didn't give us the equation how we would check for zeros here. Yeah, I'm not sure. So I'm not sure what they mean by check it. So we have two factors here. So this one's an easy one because that one just equals 0. We have x minus 5 equals 0. And I encourage you, some kids will get in the habit of, oh, okay, it's just the opposite sign of that, which is okay for a little while on easy ones. But as they get a little bit more challenging, we want to train our brain to say, okay, I'm setting this factor to 0 and I'm going to do some math to get it there. And so if you go through the motions, you're more likely to remember it. So yeah, it takes an extra second. So my roots here are 0 and 5. Okay, let's go down and let you try it now. So these are nice easy ones because they already have factored it out for us. So that's kind of nice. I'm not sure what that was. All right, so pause it, factor those, get my roots, and then come on back. All right, let's see how you did. These were the easy ones because they already did half the work for us. I got a -4 and 0, a -4 and 3. And there's my work. All right, so now we get to do some work here. Now, whenever we're using this thing called the zero product property to solve an equation, very important, we want our 0 on the right and everything else on the left. I say, you'll hear me keep saying, get all the junk to the left. And that means just everything's on the left. Notice we don't have a y here. It's kind of interesting, huh? So if we have a quadratic equation, we want to put it equal to 0 to help us find these roots. Okay, so everything is on the left. There's nothing I can factor out going all the way across. So now let's just factor this guy here. I need two numbers that multiply to 10 but add up to a 7. All right, so find those magic numbers. Yep, I got a 5 and a 2. So I want to put +5, +2. Now we go to the steps that were just above here. We want to set each one of these x plus 5 equals 0 and x plus 2 equals 0. Now again, these are kind of easy ones here, so we would do -5. And some kids are going to say, well, I didn't know, it's just the opposite of whatever's inside the brackets. But here in a second, you're going to see that we're going to get fractions equals -2. So my roots are -5 is smaller than -2. Again, that means that's where the parabola is going to cross on my x-axis on my graph. Okay, next one, see how that 8 is on the wrong side? So again, now most kids can just mentally put it over to the other side by subtracting 8 from both sides. So we can just, now we're older, we can just say x squared plus 2x, that's going to be a -8 equals 0. Now we want to factor that guy. So again, some of the kids weren't here when we were doing factoring. I picked up some new kids. I need two numbers that multiply to a -8, but add up to a 2. What numbers are those going to be? Yep, 4 and 2. One of them has to be a negative. One has to be a positive, so I need it to be a positive 2, so that's when there's going to be a negative. I know it's going to be an x times an x, so +4 minus 2. Set them to 0. Plus, we're going to -4 from both sides. Add 2. Okay. Again, everything's on the left. That's good. I can't factor anything out straight across. It doesn't look like a perfect square or even a difference of a perfect square, but I know it's going to be an x and x. Oh, yeah, it is a perfect square, isn't it? Plus 1, plus 1. So it was a perfect square. So this one's only going to have one answer. So when there's doubles like this, we only have to set one of them to 0 and solve it. And so I only have one root on this one. X equals -1. It was a perfect square. Sometimes I forget that 1 is a perfect square. All right. So now we got a big problem here. Well, more work to do. See how these guys are on the wrong side of the equal sign? Okay. So again, we can use some mental math here. I know my first term is going to be a -2x squared. Get that other 12x to the other side, I want to add 12x's to both sides. To get that 18 to the other side, I'm going to -18. And now I want to equal that there's nothing on the right. Okay. Now, just like we were practicing factoring, always the first step is, can I factor out anything straight across? And yes, I can. And not only that, my first term is a negative, so I want to factor out a -2. So what does that leave me? Whoops, I don't want to bracket yet. Well, I guess I do because I'm factoring out. So I got x squared plus 6x, nope, minus 6x's. I haven't had my coffee yet this morning. Minus 6x, and then -2 times what is a -18? That would be a +9. Okay, so now we got that out of the way. Now we want to factor this guy. And that's a difference of a perfect square because x squared is the same as x times x, 3 times 3. And if I do a +3 and a -3, nope, that ain't going to do it. They both have to be minuses because I need a +9 at the end there. So now we can't forget this -2 up here. And I think I like that now that I'm doing some FOIL in my head. So now these two guys are the same, so we don't have to do it twice. We're just going to do it once. And we'll talk about this -2 over here in a second. So we got x equals 3. So one of my roots is 3. Now we still set this guy to 0 because he is a factor. But that can't be true. -2 is not 0. So what we do is we say that doesn't make sense, and so we throw him out. Okay? So he is a factor still, just when there's no variable over here. So the only one that would make sense is this x equals 3. So my root is, only one root here, is 3. All right? So give these guys a try. I have them on the next page here, so kind of just pause your video and then let's see how you did. All right, let's see how you did on A and B. Did you recognize that that first one was a perfect square? So I got a root of 3 on that one. And then the other one, I had to do some factoring. I got -5 and 1. So pause these guys. These guys have a little bit more work to do. Got to get them onto the left side of the equal sign. Some of them you can factor out. Always look for a perfect square. And don't be worried if you got a decimal. You're gonna see we're gonna have more and more decimals. So it really kind of frustrates me, these kids that don't have a calculator at this point, and we have a lot of them. All right, let's see how you did. So I got everything on the left. I got 9x squared plus 30x plus 25. And then I noticed 9 is a perfect square and 25 is a perfect square. So it really was 3x plus 5, because 3 times 5 is 15. If I doubled the 15, I get 30 in the middle there like I needed. So we practiced that a couple weeks ago. So now I only had to set one 3x plus 5 to 0. And yeah, I got a decimal, a negative 1 2/3 or a negative 1.6 repeating. Over here on the right, wasn't too bad. Everything was already on the left. And so I needed two numbers that multiplied up to a 3, added up to a negative 4. So I got a 3x minus 1 and an x minus 1. So there's my work. I got a 1/3 and a 1. 1/3 is a repeating decimal. Repeating decimal. So, all right. So now let's talk about this diver here, like we talked about right at the beginning of the lesson. We would just want to know how long she's going to be in the air from the time she starts, which is interesting because she's already 48 feet up. And all we're looking for is when did she hit the water? Okay. How long was she in the air for? So we know this is going to be 0 here is one of them, and so we want this number out here. Now, important, because next week we're going to be writing our equations, you're going to have to write these. This is gravity right here, minus 16t squared. It's always that on Earth. Different planet, different number. This is her thrust, meaning how hard she's pushing off of the board, and so that one's kind of really for us to kind of know what it is. But we do know this. This is my y-intercept. So if they told me she's 48 feet off the ground, well, there's where my y-intercept is. She's leaving on my y-axis. She's already 48 feet up. And that's the water here has got to be 0. So again, start putting some. They're going to kind of start us writing these equations instead of giving them to us all the time. So let's go down here and write this equation where we can do some work. Now again, first thing, and we're going to say that equals 0. Okay. Now, first thing we should always do is there's something that will go into 16, 8, and 48. You're right, there is. What can we factor out? We can factor out an 8, and since our first term is a negative, I'm hoping that you said let's take out a negative 8. What's that leave us with? 2t squared minus a t, because a minus 8 times a minus t would give us the plus 8t. And then what, minus 6? All right, so now let's go down to factoring this quadratic equation out. I need, over here again, two numbers that multiply to a negative 12, but add up to a negative 1. And a negative 4 and a 3 would give me a negative 1. So again, if you want to use the lazy factor method, that's okay. I just naturally go to this because I practiced it for so long that if I took the time, I could probably easier. So factor out a 2t. T is left, minus 2. Put t minus 2 over here. And that should be a minus 3 if I'm not mistaken. Negative 3 times t is minus 3. No. Something's wrong here because it can't be. Oh, this was supposed to be a positive 3 over here. There's no negative right there. That should be a plus 3. But you see, I wasn't getting my number. So, anyhow, let's go now down here and erase this guy. So, now it's going to work out, because if I put a 3 there, 3 times t is 3t, and 3 times minus 2 is minus 6. So here's my two factors, 2t plus 3, and t minus 2. Now let's go over and set them. T minus 2 equals 0, so that's going to be a plus 2 plus 2. T equals 2. Let's take our other one. 2t plus 3 equals 0. If I divide by 2, I get t equals negative 1.5. Now we're talking about time, And it doesn't make sense to make you can't have a negative 1.5. And so we're going to throw that one out. But we'll talk about what it looks like on your parabola here in a second. But let's write our answer here. They said find the time it takes the diver to reach the water. 2 seconds to reach the water. Okay, so here's what's happening here. Is 2 seconds is out here, and this negative 1.5 is over here on the x-axis. And so kind of what happens is the parabola will really go like this. But again, we can't have a negative time because we're starting at 0 where this girl is up here on the diving board. So that's why we throw this guy out. Still a parabola, but we just throw that one out saying this one doesn't make sense in time-wise. Okay? All right, so you got one here. Now what's the difference between these two here? We both got a negative 16t squared. They're both throwing off the diving board at the same force, but this girl's at 48 feet up, and this one's 24 feet up. So would you suspect she's at a lower diving board? Should our time be less or more than 2 seconds? Let's see. I'm thinking less too. All right, so do the math. Don't forget, put it in order. And then kind of let's go with the factoring. What can I factor out first? Again, most of the time on these negative 16 ones, you can factor something out all the way across. So don't forget that step. All right, pause your video and then come on back. All right. I got 2 answers. I got a negative 1, so I threw that one out. And my other answer was a 1.5. And look at that, it was less time. She was closer to the water to begin with. And since she was going off the board with the same amount of force, well, then, the dive the effort should have been about the same, but she was just on a lower board, so she should have hit the water first. Okay? Don't forget to have units always in your answer and answer word problems with word answers. Okay? All right. On your practice page today, they're kind of helping you a little bit here. That I hope you say, okay, they set it to 0. One of my roots is going to be a 1, or my other one's going to be a 5. Okay, so the first 2 should be nice and easy. Then they broke it into a little bit more where you have to do the roots. And down here, let's make sure we write roots are, because now we got 2 numbers like the zeros. It's not an axis of symmetry. It's not our vertex. These are now roots or zeros. Okay, so on all these answers, make sure you write that. All right, so do these guys. Please don't skip the word problem. It's just like the 2 in your study guide. So if you get home tonight and you forget, or I guess you are at home, use those notes. I had a lot of kids that skipped the word problems. There was 2 of them. There's only 6 problems, and they skipped the word problems, and they were not very hard on the dolphin the other day. And that's 1/3 of your assignment right there. Okay? So don't skip them. They're the most important ones. All right. Tomorrow we have a quiz, and we'll do a little bit more practice of roots. And hope to see you in school tomorrow, but if not, we'll see you maybe on Monday. Have a good day.